Another characteristic of episodic memories is that some events are much more strongly recalled than others. Earlier in the course we talked about 3 examples of this. Flashbulb memory, where if we hear news of a dramatic, novel, emotional event, as I said, suggested like the assassination of a major political leader, later we can often recall lots of detail about where we were and what we were doing when we first heard the news. And then if we're eyewitnesses of an emotional event like a violent robbery, we tend to recall the general circumstances of the event, what's often called the gist of the situation, rather better than for regular events. And then there's post-traumatic stress disorder, where we constantly recall and relive a violent, emotional event that was very disturbing to us. To understand the mechanisms involved, let's go back once again to the circuitry of the hippocampal system. Outputs from almost all cortical areas are collected in the entorhinal cortex, then pass from layer 2 of the entorhinal cortex into the dentate gyrus and CA3. There's this massive competitive feedback within those 2 structures that selects the best targets for receptive field expansion. Once the competition is complete, the selections are passed to CA1. And in CA1, the selections are very large groups of cortical columns across wide regions of the cortex that are appropriate for receptive field expansion. From CA1, the selections are mapped back to the cortex through the subicular complex and the deep layers of the entorhinal cortex. So activity in the subicular complex corresponds with rather more specific groups of cortical columns, and in the entorhinal cortex, yet more specific. From the entorhinal cortex, outputs sometimes go direct to complex polymodal cortical areas, or are further decoded through the parahippocampal and pararhinal cortices before they go to the monomodal visual areas, for example. CA1 and the subicular complex actually get most of their inputs from layer 3 of the entorhinal cortex, deeper than the layer 2 that provides the inputs to the competition process. Now recall that the amygdala is key to enhancing the memory for the general circumstances in which highly emotional events took place, as indicated, for example, by the lack of those enhancements in patients with amygdala damage. The amygdala targets the subicular complex and layer 3 of the entorhinal cortex. In other words, it influences hippocampal system outputs after the selections have been made, and after there's been a fair amount of decoding down to selections of more specific groups of columns. So it's positioned to increase the strength of outputs, just towards cortical areas that discriminate between very complex circumstances and those areas that have already been selected for receptive field expansions. So this is the conceptual picture of the cortex as a whole, with the amygdala at the bottom left. The higher areas, like those circled in purple, record information about the general circumstances of an event. So the amygdala can target the hippocampal system to influence the outputs of the hippocampal system towards those higher areas, not changing the targets, but increasing the strength of the outputs. So there'll be rather more receptive field expansions and recording of episodic memory information just in the higher areas. And at a deeper level of description, in this case the entorhinal cortex provides most of the outputs directly to the higher cortical areas. The amygdala provides inputs to the appropriate entorhinal columns that increase the activity of active P2 and P3 population neurons, so it turns up the volume of their outputs. And that means there'll be both additional receptive field expansions and greater recording of the columns active during the receptive field expansion episode, but only in the higher cortical areas. And finally, the amygdala is also strongly connected to the ventral striatum, specifically the shell of the nucleus accumbens, which manages the selection and the implementation of strategic rewards. So in strongly emotional circumstances, the recommendation strengths in favor of recalls may also be increased, leading to a higher probability of recall in response to a wide range of trigger circumstances. For post-traumatic stress syndrome, in daily life there's a constant stream of active column populations, and the increased receptive field expansions, stronger indirect activation receptive fields, and greater recommendation strengths together mean that very frequently a population includes a subset of columns with enough recommendation strength to drive the reminiscence. And of course, each time the reminiscence occurs, the receptive fields supporting the indirect activation are reinforced.